All right, let's look at another scenario. Let's look at converging lenses when when the object is less than f. Okay, so you see that in this case we have our two focal points here, and we have our object here. So we're going to draw two of the principal rays. We only need two to get an intersection. And notice that the first principal ray goes parallel and it goes down through the focal point on the other side. But notice that the one that goes straight through the center, these are never going to meet each other, ever. They will never meet each other. So that means that the projections will meet on the other side, and the image will be bigger than the object. So this is what's happening when you view something with a magnifying glass. Notice that it's a virtual image. Dye will be negative, and it's on the same side as the object. Notice that it is going to be upright. So the magnification will be positive. Let's look at a problem. All right. So a magnifying glass has a focal length of 10 centimeters, and it's used to view a stamp that is 5 centimeters away, and we want to describe the image. So we're going to find dye and m and then go from there. So 1 over dye is going to be equal to 1 over f minus 1 over dough. So 1 over 10 minus 1 over 5 centimeters. So if I put this in my calculator, 1 over minus 5, 1 over equals negative 0.1. And if I take the inverse of that, I'm going to get dye is equal to negative 10 centimeters. So the negative means that it is a virtual image that forms on the same side as the object. And m is going to be negative dye all over dough, which is going to be negative 10 divided by 5, which is going to give us 2. So it's going to be magnified 2 times and upright. So in general, if the object is further than f, you're going to have a real inverted image. And if dough is less than f, you're going to have a virtual upright image. Now, you can't project this image. You'd have to use another lens to turn it into a real image to project it, but it will be upside down. All right, diverging lenses, by their very nature, will always produce images on the same side with the object. So, for example, if the object is closer than f, you'll have one that goes straight here and then straight away through the focal point. And then you'll have this other one that goes straight through the middle. And you notice that they're forming right here. That image is going to be virtual there too. That image, it will be virtual even if it's further away than the focal point. Still does the exact same thing. So you're always going to have smaller images form. Dye is always going to be negative, and f is always going to be negative. And it's always going to be upright, but it can never be projected. So if we did an example of that, a concave lens has a focal length of 15 centimeters. So you need to know that that diverges light, and when you plug in for f, it has to be negative 15 centimeters. and it's used to view a stamp that is 5 centimeters away. And we need to describe the image, so we're going to find die and M. So 1 over die equals negative 1 over 15 minus 1 over 5 centimeters. 15 negative 1 over minus 5, 1 over equals 0.2666, and take 1 over that, and we're getting negative 3.75. So die equals negative 3.75 centimeters. M is going to be negative die all over dough. So notice that this is negative, so it is virtual. It's going to form on the same side as the lint. It's going to form on the same side with the object, and it should be upright. So if I put negative 3.75, negative 3.75, and then I divide it by 5 centimeters, I get 0.75. 0.75. So it is upright. Let's do one more for good measure. Concave lens of focal length negative 15 centimeters is used to view a stamp that is 25 centimeters away. And we want to find die and M. 1 over die is going to be equal to negative 1 over 15 minus 1 over 25. 15 negative 1 over minus 25. 1 over equals, and take the inverse of that, negative 9.38. And magnification is going to be negative times negative 9.38 divided by 25. 25 equals, and then take another negative 0.375. So it's upright, it's virtual, because it has a positive M, so it's upright. It's virtual because it's a negative die, and it forms on the same side as the object because of it being virtual.